In the previous video, we created a strong reference cycle that caused a memory leak in our application. We then saw how to identify the memory leak using instruments. In this video, we'll fix our memory leak problem by utilizing the weak keyword. We'll also look at other use cases for the weak and unowned reference modifiers. In the previous video, we saw a simplified demonstration of a very common scenario. We have a vehicle that has a driver associated with it, and our driver who has a vehicle associated with it. This kind of circular reference is known as a strong reference cycle. This is a simple problem to solve once you know how to identify it. We can do so by simply adding the weak keyword, which tells the compiler that the reference should be weak. A weak reference is a reference that does not keep a strong hold on the instance it refers to, and therefore allows Arc to dispose of the referenced instance. Two conditions have to exist in order to utilize the weak keyword. 1. Both objects need to have independent lifetimes, meaning that they can exist with or without each other. In other words, they are completely independent of one another. 2. The reference has to be an optional or nillable value. Another option to resolve strong reference cycles is to utilize the unowned keyword to mark our reference as unowned. Unowned references work much like a weak reference in which it will not cause Arc to keep an object alive. Unowned references are used for slightly different purposes, however. We use unowned objects when they don't have independent lifetimes. In this example, we see that we have orders and order items. It would make no sense for an order item to exist without an order existing in the first place. It would also make no sense to have an order without an order item, so the order item must be non-nil to utilize the unowned keyword. Looking back at our Xcode project, the weak keyword is the obvious fit for this situation. This should resolve our problem. Let's run our application and then launch instruments. Once instruments is running, we'll tap Run on our application to create some objects and references. Okay, we see a green check mark indicating that we have no leaks. Now let's go ahead and stop our application. Our weak keyword should allow Arc to remove our references. And we get another green check mark. That means we've successfully fixed our memory leak. So we've created a common problem and then resolved it by utilizing the weak keyword. Let's look at another common use case for the weak and unowned keywords. Recall in Section 1, in closure syntax and functional value types, we created a lazy variable that utilized the weak keyword. An important point to note is that a closure is an object that can contain strong references within its scope, and that can continue to exist after the closure has finished executing. Specifically, if a variable within the closure scope has the self-reference, it points back to our life object, creating a circular reference. So, consider what's happening here. Our lazy var's self-reference is pointing at life, and life has a reference pointing at our closure. We need a way to tell Arc that one of these references is weak or unowned. We're doing that with our closure's capture list by adding weak self in to the beginning of our closure. In essence, we're telling the memory management system that our references to self are to be weak. Every time we use a closure that has a self-reference, we must have a capture list that has a weak or unowned self-reference, or we'll get a memory leak. This is an extremely important point to remember about closures. So we can address memory leaks in Swift by breaking our strong reference cycles with weak and unowned self-references. Judging by the simplistic examples I've shared, one might conclude that resolving memory issues is always a straightforward and easy process. It rarely is. Usually, strong reference cycles are created inside large, complex systems and can be terribly difficult to track down. The only true way to combat this is to always ask yourself, am I creating a strong reference cycle or a circular reference when you are creating references to objects? In this video, we have resolved our memory leak and visualized its resolution in instruments. In the next video, we'll create a memory zombie.